Okay, so last class we did several different things, but we were looking at string concatenation, and then we also looked at some conversion tools. So a couple things I alluded to is fairly soon we're going to be um, converting binary numbers into decimal numbers, writing the code to do that. We learned how to do that earlier in the semester in the class. Now we're going to be, soon we'll be writing the code that actually does that. And we're introducing some more tools into our toolbox. So last time we saw these couple of little converter things where we can pass this string function a value, and it will turn that value into a string as long as that's a reasonable thing to do. So if I passed it the number 5, it'll turn that into the string 5. Similarly, if I pass it the string 5, it'll turn that guy into the number 5 for the int version of that function. All right, but again, we're at the mercy of whether or not what we're trying to do makes sense. Go ahead.
When would it be unreasonable to turn a value into a string?
Let's see. Well, definitely object types, which we haven't necessarily gotten to yet. Maybe the easier answer would be when would it be unreasonable to turn something into an int. So, like for instance, turning the value of hello into an int is going to give us some what are we expecting? So when you ask yourself the question, if I try to convert the string hello into an integer, what would I hope the solution would be? If you can't answer that as a person, chances are Python's not going to be able to answer it very well either, right? So that type of thing. If it passes your own litmus test, the string and the int functions probably will do what you want them to do. Okay, so today we're going to look at functions. So for our assignments and stuff up to this point, we've kind of written some logic, and we maybe had a variable above there, and if we wanted to test our logic on different inputs, we would just change our variable, right? And then run the code again and see how it worked. Which is fine in the short run, but as we continue to kind of evolve our skills, it might make sense to put logic inside of a reusable chunk of code. All right, so if I kind of give a definition for functions, this is a named reusable chunk of code that we write once and can use over and over with different inputs. All right, so that's what a function is. So historically, these guys are called functions or procedures. In object-oriented programming, the name of them ended up being methods. Even an older historical term is subroutines. These all kind of mean the same thing. In the historical sense, they were all called subroutines. Then in a language like C and C++, functions were things that returned a value, whereas procedures were the same kind of thing that didn't return a value. Once we moved into object-oriented languages, we called them methods, which may or may not return a value. They're all the same thing. It's a named reusable chunk of code that does something, and we can pass 0 or more parameters to it. Okay, so let's look at the generic syntax for this in Python, and then we'll write a couple and see how these guys work. So as it pertains to our list of how human beings solve problems, the memory, the asking questions, the repetition, functions are going to fall into that repetition category along with our loops. All right, because repetition as it relates to loops says do something over and over again. Repetition as it relates to functions is here's a tool, I can use that tool in this situation. I can then use that exact same tool over here. Not dissimilar to going to Home Depot and getting a screwdriver. You can use the screwdriver for a whole bunch of different tasks. They might be all similar tasks, but like we talked about here with kind of, I don't know if I've used the phrase MacGyvering a solution in here, but have we all seen the show MacGyver? It's making a comeback. Have you seen the original MacGyver? All right, so the show MacGyver, if you haven't seen it before, and it's in season 1 of it, the new version, but the old one was on, I don't know, 15 years ago or something like that. This guy, he would always find himself in predicaments, and he would have to solve problems in terms of what was laying around him. You know, like he built an airplane out of like a lawnmower and some PVC pipe, and some things were kind of unrealistic. I think MythBusters tried to debunk several things from MacGyver, but punchline is that especially right now, but really for your entire career as a computer programmer, we're MacGyvering solutions. We're solving problems in terms of the tools we have in front of us. All right. Now, one thing I'll point out here. So I've given you a link to this page. Oh, that actually... Let me go back one. I really wanted... Let me get it to the main top level. Oh, I bet, yeah, this is the thing. So if I just go here, this is the link that I gave you on Slack. Okay, yeah, it gives you everything. So the link I gave you on Slack, you hit the little yellow box up here, and it gives you some overview. So, we've already kind of done what is Python. We've talked about the environment setup. We've messed with basic syntax, variables, basic operators, decision-making, loops. So, we're kind of sitting right around this number here. Strings, we're going to be talking about lists here pretty soon, maybe not today, as well as dictionaries. But we're skipped ahead and we're looking at functions right now. Then I'm going to circle back. We're going to look at a couple of more things that strings can do. All right, so what I've given you here is likely not an exhaustive list of everything that Python can do, but this is a lot of documentation. I'm always going to give you assignments that can be solved in terms of the things that I've introduced to you in class. So just because it's on this list doesn't mean that I'm expecting you to use it. In fact, I strongly encourage you to not use things that I haven't introduced in class to solve the problems that I give you, because typically I'm giving you a homework assignment kind of with a reason in mind. So I've given you these 6 tools, and I said, okay, now solve the problem using those 6 tools, even though there might be a 7th tool that just solves the problem. All right. But this is something you can kind of refer back to if you're looking for some documentation for something or that kind of stuff. I just happened to stumble upon it when I was bringing up Python 3 syntax for functions. So in any case, definition for functions is the word def. So we're defining a function, then the name of the function, then an opening parenthesis, then these will be the parameters. So instead of calling parameters, let's call them inputs. And that's a comma separated list of inputs, followed by a closing parenthesis, followed by your colon. And then everything that's indented underneath that guy is logic for the function. All right, we'll write a couple of these now just to see them, but that's the generic syntax for defining functions. All right, so let's go into our atom thing here. And let's go ahead and let's write a function called, we'll say def. Let's call this guy add nums. And we're going to have him take in a couple of parameters. We'll have him take in an A and a B as a parameter. All right, and then we're going to go ahead and we're going to do this 2 different ways just so we can see the difference. So a few minutes ago I referenced that historically languages like C differentiated the difference between functions that return a value and functions that don't return a value. Okay, so in a language like C, a function was something that always returned a value. A procedure was something that did not return a value. Modern languages, there's just one animal and we dictate whether or not it returns a value or not. In a strongly typed language like Java or a C# or Swift, we define whether they return a value by either putting the return type. So for instance, if I'm showing you the equivalent in Java, let me just steal this guy. We would have return type, followed by name, followed by inputs. And then instead of the indentation stuff, we'd have the opening and closing curly braces associated with this guy. Okay, so fairly similar, but since Java is a strongly typed language, we have to specify what kind of value that a particular method's going to return. Okay, and if we intend to not return a value, we make the return type void. We advertise that this dude doesn't return a value. All right. Otherwise, if it returns an integer, we would advertise the return type as being int, so on and so forth. Python is a loosely typed language, so we don't have to advertise. In fact, we can't advertise what kind of value we're going to return. So we don't have that extra part of the syntax here for the return type because it's a loosely typed language. If we return something, great. If we don't, that's okay too. All right, and so we'll see both examples here in the next few minutes. So we're going to have add num. So initially, we're going to have add nums not return a value. So typically, the antithesis of returning a value might be printing a value. All right, although you could have a function set a variable somewhere instead of printing it, but let's not muddy the waters right now. For right now, our early functions that we're going to write are either going to do something and return the result, or it's going to do something and print the result. All right, and we'll see the example here. So I'm going to initially print, and let's just go ahead and we'll add A and B together. Okay. So now if I run this program right here, what's going to be the output of my program? Oh, okay. Well, so far so good. So how do I define A and B? Do I do that in here? All right. Now what's the output of my program going to be? Huh?
Do you need to define your variables outside?
Well, short answer, well, you technically can do this. This wouldn't be a very good use for it, but you are allowed to do this. This is not illegal code as written, but we're kind of going down a path. But you're heading in the right direction, anyways. So what's the output of this program going to be? Because now we know what A and B are.
I think it'll put 9.7.
Okay, so you think it'll do the math, give us a 12?
I don't think
No output. We'll clear this and run it again.
Wow.
We didn't get a crash. We didn't get an error. Just nothing. So punchline here is functions are untapped resources until we actually call upon them. Every one of you knows how to add number. If I give you two reasonably small numbers, you could add them together in your head and spit out the answer, right? All right. All of us can do that. But until somebody actually calls upon that ability, that's an untapped resource sitting inside of your head. Correct? We all have a whole bunch of functions, a whole bunch of things that we can do in our head. But until we actually call upon them, it's just something that's available to us. We're not actually using it. All right. So in this case, I've defined a function called addNums that is capable of taking two numbers as input, not dissimilar to me saying add 5 and 3 together and you all spitting back 8. Make sense? I have to provide you the numbers you want to add together in order for you to do the work. So in that respect, he was right that A and B didn't have values. Now, hard coding values in here, though, kind of defeats the purpose of a reusable chunk of code. Okay, so in this case, since I'm changing whatever the inputs are to 5 and 7, if I say 5 and 3, you're going to spit out 12. Okay, if I say 17 and 206, you're going to spit out 12. Okay, because every single time you're replacing my inputs with two numbers of your own. Okay, so you're actually not performing something that really is meaningful, except you just always answer 12, no matter what I ask you to do. So realistically speaking, as she pointed out, we probably want to come up with the values for A and B externally. All right, all of you have inside your mind the definition of the ability to add a couple numbers together. And you're just waiting for me to provide you with a couple of numbers for you to actually add them together. Make sense? Okay, but until I actually call upon that, it's an untapped resource. So if I want to see addNums work here, I have to call addNums, passing it. Here we'll do our 5 and our 3. Okay, that'll give us our 8. Then I'll call it again, and let's pass this guy a 1 and a 2. Then we'll call it again, and let's pass this guy a 17 and a 21. All right, so I wrote this function one time, and it's written generically to take in any two values, and it will print out those two values added together. All right, so this should give me an 8, this should give me a 3, and this should give me, what, a 38? So we'll go ahead and run this. There's my 8, my 3, and my 38. Because I'm actually using that function that I defined. Eventually, we're going to be introducing our own kind of starting point for our Python things called main. So at some point, I'm going to make this comment that all programs begin and end with main. But for right now, we just have this assumed thing that anything that's not one of our defined functions is in fact our program, our main. Okay, so just kind of think about that as a foreshadowing statement. Nothing that's important to us is exact moment. All right, but we can define as many abilities up here as we want. Okay, so I can define another one. Let's do, maybe this guy's just called print val. And our parameters can be called whatever we want them to be, just like our variables. You probably want your parameters to be something meaningful. So really, A and B are probably not all that meaningful. Maybe we should call it num1, num2. Okay, but there's actually a decent reason I called it A and B here, and we'll see that in a second. But what you call your variable here isn't important from Python's perspective, as long as you refer to it inside the code by those names. If I name them A and B up here, I have to refer to them by A and B down here. That makes sense? All right, so this guy we'll call elephant, and I'll just print out elephant. So whatever you pass in, he prints. Kind of a wasted function, but a function nonetheless. So this guy, I can go ahead and say print val, and I'll pass this guy the string LOL. And now we should get LOL printed out. All right, now, what about this? What's going to happen there? Go ahead. Why do you think it's expecting to get two integers? Probably because we've only been passing in integers. Okay, so I named it addNums, but I could have also just banged on the keyboard a couple times, and as long as I didn't put spaces in there, it probably would work. Yeah, the name of our function. Typically, you want to name your function something meaningful to what they do, but Python doesn't care. That's a perfectly reasonable function name there. Completely meaningless, but perfectly reasonable. All right, so we might think that this suggests it's going to take in a couple of numbers since we called it addNums. We might also assume that, well, I've always passed it numbers before. Okay, so these guys aren't numbers. All right, well, let's see this guy. I didn't get an error. You got an error? All right, so you probably missed one of you have a little typo somewhere in there.
Yeah, I can't find it. What's mine?
So why did this work? Why did this work for 5 and 3, 1 and 2, 17 and 21, as well as hello and woot? It's related to what we talked about last class. Go ahead.
Because we didn't define them as variables or ints. Or as strings.
Okay, that's a true statement. So would that work? Now it's not so happy with those strings, right? So let's go back here. So you're right, we didn't define these guys and what they expect. In fact, in Python, we can't. It's a loosely typed language. We lack the ability to specify what kind of values it expects. Okay, we could just hope that the programmer passes us stuff that the logic works on, right? In a strongly typed language, we get to choose. And so there's kind of a benefit and a cost here. In a language like Java, if we wanted to write something that happened to be called addnums that operated on numbers as well as strings, we would have to write two versions, one that took in numbers and one that took in strings. Because in Java, it's a strongly typed language, so we have to define the kind of values we expect. In Python, being a loosely typed language, we rely on the type inference engine to figure out what kind of values we pass to it and decide is what we're trying to do with them a legitimate use of those. Okay? Well, obviously, this is a legitimate use with the plus sign in there. Run that guy again. It took hello and root and just put them together. What did we talk about last class? What are the multiple purposes of the plus operator? Concatenation. Okay, what is concatenation? Just gluing strings together. So string on both sides. All right, and it's also for addition. Move for the plus operator, and we were recently introduced to the concatenation move. All right, so depending on what kinds of values these are, this plus sign changes meaning. Okay, now what if I did that? I'll pass it a string and a number. So then the question we have to ask ourselves is, does this operator allow us to apply a string to a number? Because hello, in this particular call to the function, is going to come in and be stored inside of my variable name A. 3 is going to come in and be stored in my variable called B. Then I'm going to say hello plus 3. And we get an error message saying that the second guy here, so since the first guy was a string, the second guy must be a string if we intend to use this operator. All right, let's see if we can get the reverse error message. I'm just going to flip those two guys around. So now I'm going to try to start with an int and add to it a string. Since this first thing is an int, this plus sign, it's going to assume we're trying to do some mathy stuff, right? And it's going to say, that guy's got to be a number. Unsupported operator for this for int and string. All right. You can't just say it has to be an int because it could also be a floating point number. It could be other mathematical things. But strings aren't one of them. Correct? Now, I could do something from our last class right at the end. I can take whatever that A was, and I can go ahead and convert it into an int. So that'll try to turn hello into an int. What's going to happen then? New error, right? So let's go ahead and look at that guy. Now it yells at us and said, invalid literal for int. A couple minutes ago, I mentioned that ask yourself what you expect the result to be. So if we look at this and we say, okay, if I try to convert that guy into an integer, what do I want the result to be? We don't know, right? I mean, what's the integer version of hello? We can make something up. We can say something like, well, maybe it's the Unicode value of all the letters in here all added up. Not sure what you're going to use that for, but that might be a stretch, right? What were you going to say?
You did look at hexadecimal.
I'm going to answer no right now because you're not going to be allowed to use that tool for when we do that homework assignment. There's a way to make it work. Yeah. But when we do our homework assignment for conversion, you're going to have to do the loopy stuff and practice with logic. But there is a built-in method for converting non-decimal numbers. But I'm not going to introduce it until after we write it the hard way. Okay, but now if I change that to the string 123, well, now we can ask the question, well, if I were to try to squeeze the int out of 123, what would I expect to get? Well, I expect to get 123. Makes enough sense to me. So if I took 3 and added to it 123, I should get 126. So there's my 126. That makes sense? Now, keep in mind that the more stuff we do like this, the more we're pigeonholing ourselves into the types of values we're allowed to pass in here. Okay? As it stood before when I just had a plus b, because this operator can be applied to numbers and numbers, or it can be applied to strings and strings, I actually, regardless of how I named it, wrote a method that can kind of serve two different purposes, right? I could pass it a couple of numeric values and let it add them. I could also pass it a couple of strings and let it glue them together. That makes some sense? Now, a while ago, I kind of made a statement about one of the benefits of, well, one of the perceived benefits of a loosely typed language is you can pull stuff off like this, okay? But as he pointed out, we named our method addNums. From a programmer's perspective, our intention was to take in a couple of numbers and add them together. Just because it happens to work on strings, that had nothing to do with our actual intention, right? It's more of a coincidence, all right? If we wanted it to work on strings, maybe write another function called glue strings, all right? So we can do something like def glue strings, and this guy takes in an A and B, and then maybe as a programmer we can say, you know what, my addNums would actually work for this. So I'll actually just go ahead and call addNums and pass it A and B and let it do its thing. So now this function is written in terms of this function. But that's because we've recognized that this dude can serve multiple purposes. Okay? If we don't want to rely on our other functions, we can just rewrite this. And now A and B are related to concatenation. That's our intent. A and B up here, this is related to addition. Now you want to be a little bit more specific. Maybe we call this guy num1, num2. Then we add num1, num2 together. Python doesn't care what we name it. This is for human eyes only, right? So now when we look at a function named addNums, and we see that the first thing it wants me to send it is num1, that kind of implies that we're expecting a number. Second thing is num2. Again, implies that we're expecting a number. Maybe down here we call this guy string1, string2. So now our parameter names are implying that we want strings instead of numbers, even though both of these functions functionally do the identical thing. Our intention is a little bit different. All right, so from a good programming perspective, if we want to operate on strings and we want to operate on numbers, just because we can write the logic once and it happens to work for both, a good programming practice might be go ahead and write it twice with a different function name and different parameter names that indicate how it was intended to be used. All right? Nobody's impressed that you can write a function that happens to solve dual purposes that you may never need. All right, now both of these guys only display something. They do not return a value. So let me change up add nums here. So instead of add nums, because what this effectively does right now is it's like me saying add two numbers together, 5 and 3, and you just say the answer inside your head. I'm not aware of the answer. All right, so I say 5 and 3, and you all just kind of inside your head just say that's 8. Okay, but I never hear it. Okay, if I want to hear it, if I want to be aware of it, I would return those two numbers added together. Let's go back to this. Get this guy out of here. So now I have add nums. I'm going to pass it 5. Well, in this case, I'm going to pass it 5. I'm going to pass it 3. It's going to add the two guys together and return it. Then I'm going to pass it 1, pass it 2. It's going to add the two guys together and return it. I'm going to pass it 17. I'm going to pass it 21. It's going to add the two guys together and return it. What's the output of this program going to be? What does the code say the output should be?
Should print elephant.
Print elephant? Well, we're not even talking about that part of code. Let's get to this is, again, an undefined resource, right? This is a function. I've defined a function called print val. I've never called it. So for all intents and purposes, this guy doesn't even exist right now. So now I've defined a single function called add nums, and I've called it 3 times. What should the output of my function be, or output of this program be? 8, 3, 38. Okay, so as you suggested, the output is nothing. Okay, why not? Go ahead.
You never actually told the program to print out the return value.
Okay. This guy takes in 2 parameters, for instance, 5 and 3, and it's going to generate an 8 here. This 8 gets returned by this guy. So that line that I highlighted right there will boil down to an 8. What am I doing with that 8? Nothing. I'm doing nothing with it. Just disappearing into oblivion. If I want to do something with it, I could print it. I could store it inside of a variable and then print out the variable. That kind of stuff. Okay, so now I'm calling add nums on 5 and 3, and I'm directly printing the answer. I get an 8, but from that point forward, I've lost that result. All right, I didn't store it anywhere. The next time I call add nums, I'm passing it a 1 and 2, I get a 3. I'm storing that 3 inside of answer. Then I can print out answer. Now I could actually call add nums again, passing it answer as one of the parameters. And add answer plus 21, which should give me 24, storing the result back into answer, so overwriting what answer used to be, and then print out the new value of answer. So this is going to print out 8, the result of the first call to the function, which I didn't store anywhere, but I went ahead, and this guy ultimately is just going to boil down to that. That's what's ultimately going to happen. That's just as good as me saying print 8. Then I'm storing a 3, the result of that, inside of a variable called answer. Then I'm printing out answer. So the next thing I should see is 3 on the screen. Then I'm calling this function again, passing it the current value of answer as the first parameter, which is a 3. This integer literal 21 is the second parameter. 21 plus 3 is 24. Storing the answer, storing 24 back in answer. And then I'm printing out the final value of answer, which was 24. Does that make sense? Now I'm actually utilizing the values that my function generated for me. Ooh. All right, so similarly, and actually let me show you a a new little tool, I guess. So I'm going to go ahead and we're going to say s is equal to hello. Now, we've written functions that print strings, right? But we haven't written functions. We've written logic that prints strings. So if I want to say def print string, and this guy might take a, actually it might let me use that. We'll see. That could be a reserved word, str. So I'll take a string in as a parameter, and then I'll go ahead and say for C in string, print C. And that should print out the contents of that string. All right, let's get rid of, well, actually, I'll leave those guys up there for right now. Now I'm going to go ahead and call print. I'm going to probably want to do this after I've defined my string. Print string, I'll pass it s, and this should, my string s, which is hello, should get passed into this variable str. Then I'm going to go through every character in str, and each one's going to be equal to C. So it'll be an H, then an E, then an L, then an L, then an O, and I'll print that character. All right, go ahead and run this. So there's my HELLO. And if I wanted to, I can call print string and pass it elephant, and now it'll print out elephant after it prints out hello. So one tool that knows how to print out any string I pass it. So there's the elephant. All right, so now up to this point, this is how we've printed strings. Now, if I want to get an individual element in a string, okay, I want an individual element in a string. So for instance, I have s here. If I say s, open square bracket, 0, this is going to print out an H. So there's that H, it just printed out. The element at position 0 in my string is an H. The element at position 2 is an L. There's the L. So I can actually gain individual elements of my string using square brackets like this. If you've seen Java before, this is kind of like the char-at method in Java. This allows us to access an individual element of a string. Now, what if I tried to do this? We'll try to change the value at bucket 2 in my string to a B. And then let's go ahead and print out the string. So this is 0, 1, 2. So the first time I print out the string, it would be hello. I'm using my print string to do that. Now the next time, if it allows me to change the value within the string, this L right here would actually become a B. So it would be heblo that should print out. All right, so notice here, strings are read-only, just like in most modern programming languages. I am not allowed to directly replace a value inside of a string. Instead, I could rebuild the string, right? I could build a brand new string that has everything in it before bucket 2, everything in it after bucket 2, and instead of concatenating what used to be at bucket 2 onto the string, I can concatenate on the B. Does that make sense? So I could write a function called change string. Def, yeah, we'll call it change string. And this guy will take a string as a parameter, a pause, and a new char. Okay, and what this guy should do is it should return a new string with bucket pause in the original replaced with new char. For example, change string of hello to B should produce heblo. Like that. That makes sense? So that's what our homework's going to be, to write that guy. Now, to kind of give you a little nudge in the right direction, I'm going to rewrite print string out here. Because one annoying thing about our print string so far is that it prints it one character at a time, right? And you get this, all your strings are vertical. It might not necessarily be preferable to us. But now we know that we can actually go through a string one element at a time. Now, we can do this a couple different ways. Okay, I'm going to do it our natural way first, and then I'll rewrite it in the not necessarily unnatural, but in a way that practices accessing the individual buckets. So rather than directly printing out my string one character at a time like this, what I'm going to do is I'm going to go ahead and I'm going to create a string called answer. I'm going to start that off at the empty string. And I'm going to keep tacking things onto it. All right? So as I go through my string, I'm going to say answer is equal to answer concatenated with C. Oh my gosh. And then finally, I'll print out answer. So let me get rid of some of these things here. Well, actually, just so we don't, I'll just comment these guys out. Just so it's not messing with the output. Well, we can call it both of those. That way I can still paste this up there and you can see all the stuff we did today. So now my only output should be from these two print strings, right? So, because I didn't print the other stuff. So print string on S should print out hello, but the hope is it would print it out all in one line. Because how does print string work now? Well, I start off by creating a brand new blank string. Then I loop through every character in my string that was provided, my string parameter. And for each one of those, I concatenate onto my current answer the next character and store the result back in answer. But now the question we have to ask ourselves, is this operator allowed for a string and a char? The error messages we've seen before have always indicated that that second thing needs to be a string. That plus operator only works on strings and strings. So let's run this. Oh. My indentation stuff. Did not save that. Equals add nums 1, 2. So it wants this guy to be. It's complaining about indent. Oh, it's because I didn't put anything in here. Or just for the moment. Let me just cut this guy real quick. It wants my function to have some content in it. I didn't even put one line in there. That's why it wants that answer to be indented. So it printed out hello and it printed out elephant. So what did that add to our knowledge? It added to our knowledge that, you know what? Concatenation here will work on strings and chars as well as strings and strings. If it hadn't, I could have converted that guy into a string, right? Could have made him a string each time and it would have still worked. All right, so now my print string does it all on one line because what I'm doing here is I'm building up the string I ultimately want to print. Then I'm printing it. Now, realistically, you could have just said, well, why didn't you just print str? Because then you're effectively duplicating it. But that's okay. That might come in handy on another homework assignment, possibly. But now let me show you the alternative real quick. So just to deal with the accessing the individual buckets. So we're going to say for I in range 0 to length of string, set answer equal to answer plus string at position I. So rather than going through the collection of characters in my string, I'm going to go through all of the indices of my string from bucket 0 to its length minus 1, and I'm going to tack on to my running string the character that lives at bucket I each time. This does the exact same thing, the exact same logic as we just had before. It's just accomplishing it in a little bit different way. Now I actually have access to which bucket in the string am I currently working with. That make sense? All right, so I'll go ahead and I'll paste all this up on Slack so you have our code from today. Your homework for next class is to write and test change string. Change string should build a new string that is everything from the string we provide as a parameter, with the exception that position pause should be replaced with whatever new char is, rather than what used to be there. That makes sense?
No, we don't.
All right, well, it should do this right there. So read that, and it should make some sense. That's what it should do. All right? I will see everybody on Friday.
Hey, Doctor.
What's up?
Can't be here on Friday. I have a wrestling meet.
Okay, but you can still do your homework and turn it on
Yeah,
Friday.
yeah.
Okay.
I'm making sure I'm not working half.